Okay, I think I'm ready as ever to begin. Happy Tuesday, everybody. Praise be the spiral. Have I got? Oh, I've not got my spiral t-shirt on today. Never mind. Hope you're all doing well. It's been an interesting couple of days, actually. We've got oh, it's just a little bit too quiet. We've got the emulator working quite well. Thank you for the resub, Emma. Very much appreciate. 23 months. Wow. I'm just gonna nudge the alerts up slightly. I did knock the volume down slightly on request, so I'm just trying to get it just right because I do need to be able to hear it in my ear properly. So, but yeah, thank you for the resub and cheers. I'm drinking a tropical fruit, mixed fruit tropical Copperberg tonight. Cheers. Just because I had a couple of cans in the fridge and they've been there a while, so I thought I'd get rid of them once and for all. So I got 2 cans of that to drink tonight. So yeah, the XEMU stuff has gone really well, or I need a better way of pronouncing that. Shimu. No, it doesn't sound right. Yeah, can barely hear anything. Low sound. Okay. How is the sound for everybody? Is it too low? I mean, I could up it slightly. If I just nudge my volume up a bit like that, hopefully you should get a better volume on me. Got to be careful though, so it doesn't clip. So let me know if it goes funny. I'm just still okay. I've upped it slightly. It's clipping on there. That's my issue. How about now? It's still clipping. Damn it. It's tricky. It is really tricky to get the balance just right. Sound like a robot. Damn it. All right. Yeah. See, I have to. This is why I have to turn my volume down a little bit. And there you go. No, we're clipping. Okay. I seem to have no end of problems, don't I, with things. It's a nightmare. Way too loud. Okay. Hopefully it's okay now. I've nudged it down a little bit. It's difficult because I don't want the music to be too loud. I don't want the music to drown me out. I should be lowering the volume of the music as I speak. The other problem as well is that the alerts can be too loud as well, so it's tricky to get that just right. So I'll leave that there for now, and let me know if they are too low. I'll try and get the balance. I'll try and get the balance just right. I don't know why I'm so low. It's kind of it's frustrating. I don't know. I can never win, can I? It's either too low, too laggy. Something's not quite right all the time. Anyway, not to worry. Cheers for the bits as well, Doxter. Appreciated. Oh, so yeah, Doxter bet me that my parcel to him would arrive before a parcel he got from Poland. My legs are too short. Really? You don't see my legs. You never see my legs. And he lost, so he lost because my parcel still hasn't arrived. But hopefully, oh, that's why I'm too. Well, you're assuming that I stand up while I stream. Maybe I do. Maybe I am stood up. Maybe I'm only 3 foot high. Anyway, to go back to what I was saying, and it kind of leads on to what I want to do tonight. Hey, Nikomo. Yeah, XEMU is getting better and better. We've managed to run some stuff that has disk access for the first time, using my floppy disk access. That is, it's just due to a small bug in the disk buffer in XEMU. There's a data register that you can read, which reads 1 byte from the buffer and then it advances to the next index, and that doesn't seem to be working. So I've just changed my routine to just read the buffer directly rather than through this data register, and that seems to work fine. But it's still a bug. In fact, I need to write that down because it is something I do need to I do need to write a test for and get it fixed. So I think I can't remember the register now. I'll call it a floppy data register. I don't know what that is. Likewise, there's been a few fixes with various things such as horizontally tiled sprites, raster rewrite buffer stuff, negative raster rewrite buffer coordinates, alternate palettes, horizontal flipping of 16 color chars, NCM mode chars. It's going really well, actually. It's going really well. And I'm slowly getting used to the code as well. I think I've submitted 2 or 3 pull requests now that have made it into the code. So that's pretty decent. I'm getting along with it now. So that's kind of what I want to do for the next couple of streams for the Mega65. So I want to kind of take a look at a few different areas of the Mega65. There's a few reasons for this. Firstly, it's going to be a great help for the emulator. If we can do the dual kind of test that I've been doing where I test on the hardware and the emulator at the same time and make a note of any differences. I think the emulator is in a good enough state that we can do that now. And if there are any significant problems, I can take a note of that and then write tests through the throughout the next couple of days to try and give LGB, Hananda, myself something to kind of test things against, so we can see if the issue's been solved or not. Sorry, just moving some napkins out of the way. Secondly, I think it's a really good idea to kind of touch on these various areas of the Mega65 because it gives you some example code that you can kind of work with. We get to talk about certain things. We get to learn certain things together as well. And in that vein, tonight we're going to do DMA stuff. So let me start by just giving you all some points, and then I'll explain exactly what we're going to do. There we go. There's your points. Let me start the races. There we go. Is there something we can't do with the Mega65? Write Z80. Well, you probably can. You could probably write a Z80 interpreter quite easily. In fact, you can write Z80 because you can just load the ZX Uno core up. So if you want to, you can. You can load the ZX Uno core and write Z80. Why you'd want to, I don't know, but you can. Well, you can't buy it yet. Yeah, that's true. You can't. Yeah, so tonight we're going to do DMA. So I've done a bit of DMA for various things. So DMA is direct memory access. I think that's what it stands for anyway. That's what I always think of it when I hear the word DMA. Basically, it just means a way to quickly copy chunks of data from one area to another, or fill areas of memory with data. So the DMA on the Mega65 is very quick indeed. I can't remember the exact speed, but it is very, very quick. So what it lets you do is do things like clear the screen, shift data around if you want to do some kind of character animations, or you want to shift map data. So you want to shift the screen around, you can do that very, very quickly with DMA. So we're going to go through how the DMA kind of operates tonight. We've touched on it briefly. I'm going to use the macros that I've included, but I will explain exactly kind of what's going on with each of the macros. And then we'll look at using the DMA to do some fun stuff as well, because DMA is extremely powerful on the Mega65 because we have a thing called Fractional Step Dma, which allows you to move the source and target kind of destination pointers at increments that are less than it, that kind of non-integer increments. So in the same way we were drawing a line on Checkanoid, and we were using the kind of the integer step and then the fractional step to kind of to move to move kind of slowly at a given gradient. We can do the same with DMA. In fact, we'll try and do a very simple line drawing algorithm on here as well. Okay, so let's I did start the race and give you money. Okay, cool. Right. I'm Oh my god, we're running out of backgrounds, and I need to get some more backgrounds done. I don't know how many series you've still not discovered, and I haven't added any more in recently. So, um, but yeah. So I actually didn't know what I was going to do tonight. Um, I honestly had no idea what I was going to work on. And then Amok was asking questions about the rotate sprite algorithm, and whether or not we could do that on the Mega65. And I thought, well, let's do a stream or two based on that. So we'll start doing some stuff tonight, and I may extend it on into Saturday and do a little bit on Saturday as well. And at the same time, we can be kind of keeping an eye on whether the emulated performs the same or not as the as the real hardware. It should do, I think, for the most part. There's only a couple of things. Well, in fact, in terms of what we're going to do tonight, there's only one thing that might not work, but I don't think we'll actually come across it, which is if you try and DMA across a boundary, a 64 kilobyte boundary, it may not work. So, what classic systems would the Mega 65 be in the same ballpark? Probably the Amiga 1200, I think, is probably the closest thing to it. But in a lot of respects, it's better than the Amiga 1200. For instance, it's got better sound. It's got much better kind of choice of tile. You've got different ways you can display the screen. With Amiga, you're kind of locked into kind of bit planes and doing stuff like that. But you've got a choice with the Mega 65, and the DMA stuff, I think, elevates it just a little bit beyond the Amiga 1200, and especially with the raster rewrite buffer as well. I think it elevates it just a little bit beyond that, but very, very close to the Amiga. It's also got more colors, I think, than the Amiga. I think Amiga has, I don't know what the palette size is in the Amiga, but you can definitely get more colors on screen, I think, with the Mega 65, and I think your palette choice is bigger as well. I think, I don't know the exact color specs of the 1200. Bit planes didn't scale. Yeah, I mean, we don't have okay, so very, very similar in terms of palette. In fact, I think in that case, the Amiga is slightly more, because the Mega 65 is 8 million colors palette, 256 on screen, although you can use trickery to get way more than that. But you don't have to use bit planes to do all those colors. You can use full color character mode, which basically treats the screen like one giant full color bitmap, basically. Well, depending on how you lay it out. Okay, so let's do some startup code here. So I'm just going to nip into this this code here, just because I can't be bothered typing these out every time. So I'm going to copy paste this. Going to create a new file. I'm going to call it main.s, because that's what I call all my startup files. And we'll see, crashed already. Wow, that's a good start. Okay, there we go. Strange. And we'll get our basic upstart, and we'll copy everything up to this point as well. I kind of should make this a macro maybe to do this this entry stuff, because I do the same entry every time. Essentially, what I'm doing is doing the standard C64 banking. I'm not even. I need to do some tests around this. I'm still not sure if this is necessary or not, but I do it anyway. Because I think you still need to kind of map IO right correctly and stuff. So I just use this because it's what I'm used to using, and it seems to work absolutely fine. Then enable 40 megahertz and VIC4 registers, which are macros, very simple macros. You can go and take a look at those. In fact, let me set the layout so we can. There we go. And let me put the macros on this screen here. There we go. So the enable 40 megahertz is a very, very simple. It's just storing the value 65 for Mega 65 into 0. So it's a special kind of knock value, if you like. It doesn't actually store that value in here. If you were to read that value straight after, it wouldn't be 65, but it allows you to just turn the 40 megahertz side of the uh, the 40 megahertz of the chip on, and then enable VIC4 registers. First of all, you have to set your kind of mapping so that all memory is unmapped, if you like, and then you have to enable the VIC4 by knocking these two values. So again, this is a kind of a knock register. Just setting values in here in particular order will do various things. So A596 will give you VIC3, 4753 will give you VIC4. I don't know what relevance those particular values have, but those are the values that have been chosen. I'm sure there is some relevance to those as well. So that's what we're doing there. I've actually got disable C65 ROM already as a macro. So let's replace this here. So this basically turns off write protection for the Mega65 ROM, which is, well, the C65 ROM, which is up at 20000. Hey monsters, welcome. I hope you're doing well. You come to watch me try and discover the the DMA stuff. So yeah, so what we're going to do once we've got this set up is we're going to work through how the DMA works. So we'll start by doing some very simple things, like just copying stuff into the screen. And we'll start by doing a clear screen and demonstrate exactly what that is doing, and clear the screen with a particular color, which I use in fill jobs in DMA. So we just give it a byte and we say fill this area with this byte. And then we'll move into copying. So we'll copy some. We'll set up a screen somewhere else in memory, and we'll copy that screen from there to the actual screen using DMA. And then we'll do some stuff like zooming in on the screen. So you'll be able to see how fractional DMA allows you to smoothly zoom in and out of a screen. So long as you set the old palette bit without looking at it. I've actually, because I've got so annoyed with that, I think I've memorized it. I think I have. We'll see in a couple of months time when I go to use it again if I've forgotten it or not. So let's I'm going to copy that over into here. Actually, should probably update this with more comments and just allow these to stay here. So disabling the C65 ROM doesn't actually unmap it. So what I'm going to do is I'm also going to move this into here, which will unmap the ROM as well. So what that's going to do is going to do two things now. Disable C65 ROM is going to, first of all, turn off the write protection, so you can actually write to this area. Hey, Deft, welcome. And then the second thing it's going to do is it's going to unmap the C65 ROM. So by default, the ROMs map into some areas up. I think it's C000 that it maps into. So if you don't unmap it, you end up with a ROM there that you can't do anything about. So we're shortening this slightly so that it's all happening here. I don't know why these are happening here. Let's move those down so that they kind of go with the other interrupt stuff. There we go. And then the last thing here is just a VIC2 shift. I'm going to turn that off. I don't think we need that here now. Basically, this is because by default, the C65 is just scrolled over by 1 pixel. It's a bug, but it's a bug we do need to take care of. Unfortunately, it's not a bug in the Mega65. It's a bug in the original C65 code. So I don't know if that's something that's we plan on resolving or not, or if some code relies on it and therefore we can't. So we just have to leave it like that. So okay, so this is our basic setup, and you can see it doesn't really do very much. It's just going to set up, and then actually we don't want it to return. We want it to jump to a loop here. Okay, so this is our main loop, and this should set everything we need up. This is, as I said today, actually, I think it's the right term. It's our bootstrap code. It's the code that initializes everything before we actually run the main code. So this is our bootstrap code. I think that's the right term for it. I know it's definitely a term in OS development. I don't know if it's the right term in just standard development. I think it is. I mean, it kind of fits. Let's go with that. Pull yourself up by the bootstraps. Yeah. It's this. It's your self setup. Yeah. It's your kind of self initialization. If you like. So the actual macro code that's in here. What I'm going to do at some point is unfortunately I've got two Git repos with the macros in, so I'm going to get rid of the one where it's just the macros on its own, and I'm going to put the current include folder that I have here, including AC parse, all into one repo, which is the Mega65 toolkit or whatever, and then I will make this repo have a sub repository. If I think I can do that in Git. I know I could do it in SVN. I'm pretty sure you can do it in Git as well. So when you check out this, it will automatically check out that as well and put it into an include folder. So I don't have to kind of automatically update this. So that should help when you check things out. The only thing you'll have to do is you'll have to I may put like a setup file in which when you run it does an npm install and stuff. Git recursive, yeah, and something like that. I definitely remember doing it on SVN. I can't remember if I'd done it on Git though as well. SVN. Oh God, I'm so glad I don't have to use that anymore. Okay, anyway, that's our base code. So right, what we're going to do now is we're going to do some DMA jobs. So what we're going to do is we're going to set up a couple of jobs. First, we're going to have clear screen color or clear. Let's just call it clear color and clear screen. Okay. These are going to be DMA jobs. Before we do that, though, we should actually set the screen up to be what we want. So I want to do this in 40 column mode. So let's have a look. What have we got? Yep, 40 column, disable extended attributes. So there we go. And what's that one? That's the full color character mode. That doesn't matter. This should be enough for now. Just want to set 40 column mode. So all our Vic4 setup will be here. Okay. And put our DMA jobs here. Okay, so we're going to do, we're going to call clear color. Oh, God. I think I need a slightly bigger keyboard, you know. I think I'm getting, my fingers are too sausagey to use this keyboard properly. It's not quite right, which is annoying because I kind of spent a long time trying to find the right keyboard and I thought this was it. Obviously not. Plus it's an excuse to just buy more keyboards. I like keyboards. It's not like this one takes up a lot of room. This would be nice as my Linux keyboard actually. So I don't have to have a massive thing hanging on my desk. So it's the Epomake. Yeah, it's the yeah, well it's one of those things, yeah. It's a nice keyboard. It is a nice keyboard, but I think I just struggle to type on it quite correctly. And I don't know what it is. I can only imagine it's something to do with the profile of the keys or the profile of the keyboard. Something I'm not sure what it is, but need a finger gym to trim them down. But yeah, I might. I kind of want to get my son to make me a custom keyboard, so because he's been doing custom builds, so and I know he likes doing those things, so I might get him to do that. But what I need to do is try out a few keys first and keyboard profile shapes. So I'm not sure how to do that. I really like the Mega65 keyboard. Maybe I just try and emulate that somehow with the kind of concave profile to the entire keyboard with the way the top row is kind of higher and then they go lower as they go down, so it kind of creates a curve as it goes down, which is nice. And I kind of want my F keys back. I don't care about the num pad, but I kind of want my function keys back. I've got used to using without the function keys, but it'd be nice to get them back though. So, and the good thing is as well is I can take these are all exchangeable switches as well, so I can take all the switches out if I want to. So I can get something with different switches and then try them out. And if I don't like them, I can switch them out for these blacks instead. So. Okay, anyway, let's do this. So Dma. So let's start with a simple Dma. We'll just use the macros that we've got, and I'll show you how those work. So we've talked about these before a few times, but let's go over them. Again. So the main function you're going to call is run Dma Job. This takes a pointer, to a memory pointer. I'm just going to call it job, the memory pointer, and we're going to put that there. And that's basically all you need to do to run a Dma job, is you just need to call that function and point it to somewhere. And what that function does is it takes the address, the memory address, sticks it in a few locations in memory, namely D701, 702, 704, and 705. The reason actually, I mean, it doesn't really matter if this is written first or not, but the important thing is that this is the last thing you write. As soon as you write to D705, it begins the job. And I'll explain what that means in a minute, but it means you have to write this last, because if you try and write this first, you might have the wrong address and it will try and get the instructions from somewhere else. So, yeah, so this one has, yeah, it's got no function keys, no numpad. No end or print screen or anything like that. It's just, well, actually, quickly. Oh no, you can't see it. There you go. It's very, very tiny. It's 60%, I think it's called. It's a bit dirty as well. I need to clean it. I can't remember how many keys it is, but it isn't many at all. Actually, does it say on the thing? No, it doesn't. Well, it's a bit dirty. Is that what she said? EP84. I'm going to write that down because I do need to have a look. I might take a gander and try and order one. Oh, it's tiny. No, this is actually a Chinese make called Sky Lung. But it came quite well recommended, and they had some quite nice keycap sets that came with it. But I think it's just an EPO Maker clone. I think that's all it is. But it's a nice keyboard. It is a very nice keyboard. I just don't think it's quite right for me. I feel a little bit funny with it. So I tend to kind of mistype. I mean, I tend to make a lot of typos anyway. I'm very error prone when it comes to typing, but I think with this I type way more errors than I did previously. So yeah. Okay. So what does this do? When the job starts, what it does is it halts all CPU execution, and then it looks at this job, and this job tells it exactly what to do next. And so it consists of two main parts, and we can kind of enhance it with extra sections. So the main part that it absolutely has to have is a header. I've conveniently created a macro for this, and the header just tells it which request form. There's two request formats. There's F011A and F011B. So I use F011A. The difference is quite small. It's not a huge difference. It is documented in the manual somewhere. I'm just trying to find it. But I'm using F011A. I couldn't tell you why. It's just the one I've been using. So yeah, so one is 11 byte, one is 12 bytes. I don't know what the 11th and 12 bytes are. One is longer than the other. Yeah, for whatever reason. But I use F011A and I've not found anything it can't do yet. So that's fine. So that's the very first byte. You can see that here. The very first byte is tells it which request format as you got F011A and F011B by changing this byte here. The next two are absolutely critical. You need to set these. This is our source bank and our destination bank. So what do I mean by bank here? The DMA looks at banks as 1 megabyte blocks of memory. So in terms of your addresses in memory, that is, oops, hang on, 64. Yes. Is that right? No, hang on. 64K. There we go. So that is the first megabyte block. So from 0 to that is the first block. So this is called bank 0 and so on. That's bank 1. And this is what we call banks. In terms of DMA anyway. So I like to think of banks as there's two types of banks in DMA. There's the bank, which is the 1 megabyte blocks, and then there's sub banks, which are 64 kilobyte blocks as well, which I will show you when we come into the main chunk of code in here. Again, you don't really need to know that if you just use the macros. All you really need to know is what megabyte block. So for most things, it's going to be 0 for both, right? Because you're going to be copying probably from uh, one area of kind of your 64 kilobyte block into another area of that, and it's very unlikely you're going to be touching anything else, except in one case, which is with color RAM. And I'm going to put the color RAM address up here. You can see color RAM is actually in this area here. So if we take our megabyte block out of it, our megabyte block is this. So this is the, as I was showing you with the banks down here. In fact, let me copy that and just undo just to show you again. So you can see if we want to know what bank we're in, we just get rid of the last 5 digits here and look at the next digit, and it tells you what bank we're in. So get rid of 5 here, and we're left with nothing. So it's bank 0. Get rid of 5, and we're left with bank 1. So that's how we know what bank we're in. I'm going to leave that there in the code. So when we look at the color ramp, we can see that we're in bank 255, because if we get rid of the last 5 digits, we're left with FF. So we can put that into our DMA header. This is our destination. So our target, our source is 0. Our destination is FF. Source can actually be anything here because we're going to use copy. So it really doesn't matter if you set a source or not. I think by default it won't set a source. No, it does actually still set it. You probably don't need to include that source here. What is the first half of bank 255? I think it's floppy floppy sectors and stuff. It is all noted in the manuals somewhere. Let's have a look. It is let's just ROM banking. It's just compatibility ROM. There is something in here. I'm sure I've seen it somewhere. HDMI I2C registers, SD card controller buffer, F011 floppy controller buffer. Actually, they're in the upper area. Wait, this is all in a weird order. Oh no, that's D6. Yeah, that's in the lower part of it as well. Well, you see, from actually, that's surely that should be that. That doesn't look quite right. Hang on. Oh no, that was right. Sorry, that is correct. I'm looking at hypervisor. I'm sorry, I was reading completely the wrong area. So the lower area is it just says future IO expansion, but just below FF7E000, the VIC4 character ROM is there. Write only, so it means you can actually change the character ROM there. So that's kind of interesting. Are you telling me read the manual? Who reads manuals? Oh, believe me, you'll be reading the manual a lot with the Mega65. There's an awful lot of memory and stuff in various places to learn. So you will be reading the manual a lot, I promise you. This is going down very well, this cider. I've missed cider, that's for sure. There's a manual. You know there's a manual. Don't pull my leg. Okay, so we're setting our source, so which bank we're pulling from and which bank we're pushing to. And then we can just do a Dma job of some kind. So we're going to do a fill job. And the fill job is also fairly obvious. We've got our byte, our destination, our length, and our chain. So the byte that we want, let's fill the screen with black. So our byte is going to be 0. Our destination is going to be coloram. So we're going to take, actually, if I just put coloram in here, will it work? Let's have a look. Destination. Yep, it will. All right. So and our length is going to be the screen size. It's 40 times 25. We're not going to do 16-bit characters here, character indices here. We're just going to use the normal indices. So it's 1000 bytes. And is it chainable? False. So let's talk through each one of these one at a time. So the source byte is very obvious. It's just the byte that we want to copy into the area. This is our destination location. Now, if you were not doing the macro, you would have to do some kind of splitting of the color RAM up here. So the color RAM is FF80000. Oh, hang on. Yeah, let me move that up. So this is our color RAM. If you were to fill this job in yourself, you can see here how it's split up. You would have to put this as your destination, and this byte on its own is your sub bank, as I call it. So we're writing to bank 255 sub bank 8 at destination 0000, and this is why on at least on XEMU it's changed now on the hardware. If you try and fill beyond the, so like if I set the amount to 70,000 here, what would happen is it would get to the end of this. In other words, it would get to FFF, and it would just wrap back around to 000 without incrementing this. And so you have a bank wrap issue. We don't have that issue on the real hardware, and it's something that will change on XEMU eventually. It's about the only thing I think won't work tonight, but I don't think it will be a problem for us. But as I say, you don't have to do this. If you just use the macros, it will do it automatically for you. You can see there it's doing the split of the data for you. Length is straightforward. This is just how many bytes you're gonna copy from one area to another, or in this case, fill in that area. And chain just allows you to add an extra job. So if we wanted to add another job on the end of this, we could do true like that, and then we can just add another job here as well, in which we could give it another header, and we could say, okay, fill. So for instance, we could do fill the first line in black, and then fill the rest of the screen in white like this. And that will run both of these. And you just have to put a false at the end to say this is the end of the chain. So what happens when you run the Dma job is that the Dma magic chip, which is the chip in the C65, or the emulated version, the kind of the VHDL version in the FPGA, will go through this list, reading the data and working out exactly what it needs to do. So in this case, it will read this header. It will say, okay, I need to copy this byte 0 40 times, starting at this location. And then it goes and does that. And then when it's finished with that, it goes, okay, it is chained, so I need to do another thing. So I'm going to look ahead and see what else I need to do. And it says, okay, I need to copy this 01 into color RAM, actually plus 40 we want here. 960 times to fill the rest of the screen with 1, and there is no chain. So when you're done, you're finished and you can exit. So at this point, when you run the Dma job, the CPU freezes. No other things will run. No other code, 45GSO2 code will run. It will just freeze the CPU at this point until the Dma job's finished. It's very quick though, so it happens very, very fast indeed. So let's just do that and try that out and see how that works. And then we'll move on to clearing the actual screen. Hopefully this is. Oh, what happened there? Something weird happened with my. Oh, because I've got in my make file. Let me fix my make file. So here's my make file, and I've still got the asset price stuff in here. So I'm just going to delete that. I don't need that. Should be fine. All right, cool. Also, I've been building building XEMU without SDL update, so I get this extra message, but you shouldn't have this issue when you're running. So you can see there we've switched to 40 column mode, and we've filled the first two lines in black, and then the first line in black, and then the rest in white. You don't actually see anything on the second line because there is nothing if you split into. Yeah, sorry, it's not really a make file, but it's they make you call it make. So for me, it's as close to a make file as Kick's going to get. So, but it is a batch file, yeah. Um, yeah, there you go. So that's using DMA to fill the coloring in the screen. So let's just change that back so it's just doing black. So we're not doing weird color setups. So we'll do 1,000 bytes at color ramp, and then we're going to do the same thing, but we're going to do it with clear screen instead. So we're going to copy this down to here, and we're going to do the same thing, but now we're going to do screen RAM. So let's take screen RAM as a vector, as a constant even, and go and set that up. So screen RAM is at 0800 by default. We're not going to change that. So one thing you can do with this bank as well is if you want to work out what that is, if you don't want to think about it at all, you can just take your address, shift it 20 times in that direction, because we're knocking off 5 digits. Each digit is four things. Yeah, we could chain. Yeah, that's a good point actually. Let's chain them both together. Let's call it clear screen and color. There we go. There we go. So we can do the same here as well, just so we know which bank it is. And there we go, and that should hopefully fill the screen with the @ symbol in black, if all is well. Notice how the first job has got a true, and then we chain the second job, which is cleared in the screen with a false on the end. So I want to do some little experiments with this as well. So let's just see if this is working on both. So there you go. So there's the real hardware, and there's XEMU, and they both look exactly the same. So that's good. So I want to try some little experiments here. So what we're going to do, I'm going to try changing some values with the steps, because what I want to do is play around with this macro here. I just want to see what happens if I try and step the source while I'm doing this. So what do I mean by step? So what is source and destination step? So if you're copying from one memory address to another, so let's say this is our target, this is our source, right? And the values here are blank at the moment, and we want to copy these values from here. So by default, the step is 1. So when you copy, it just takes the value from 0, puts it in 0. Then it adds 1 to both the source destination and 1 to the target, sorry, and 1 to the source. So we get 1, 1, and we copy B. But what you can do is you can change this. So instead of it copying and advancing by 1 on each, you can say, I want to advance the source by 2 every time. So you can say, okay, first I'm going to draw A, and then I'm going to advance by 1 on the destination, but I'm going to advance by 2 on the source, and it will do this instead. So now it's skipping characters. So that's oh my god, bots, do your stuff, Andy, or the mods. So annoying. So what I'm hoping we can do, and I don't know if this is going to work or not, we're just going to try it out. I'm hoping we can advance the source, even though all we're doing is adding a byte onto the screen. So what I'm going to try and do is I'm going to try and add a source step in. So by default, the source step is 1. If you don't change anything, it remains as 1. But what I'm going to do is I'm going to put a step in here. So I'm going to do Dma step, and then it needs a source step and a fractional. So by default, it's this. And you don't have to set this up to do this. It will just automatically do this. Okay, let me ban these guys. Hang on. Oh, there you go. Already been done. Thank you. Thanks, steps. So by default, this is what you get, and therefore you don't have to include this. In fact, you'll see in the code here is if you do try and do that, it won't put any of these in. So if your fractional is 0, it won't do this piece. If your non-fractional is 1, it won't do it. So actually, this won't actually add anything. There's still a couple of background series I really want you guys to discover, but I'm sure they'll come at some point. Okay, so what I'm going to try and do is I'm going to try and oh, actually no, because the source step isn't advancing. Okay, let me just try setting it to 2 and see what happens. I don't think this is going to do anything. It'd be nice if you could advance the byte as you go along, but I don't think it's going to work, unfortunately. Let's try it. Let's see what happens. So I do apologize in advance for all the weird messages that Xemia is going to throw up. I'm just not upgrading the DLL. So okay, so no, that doesn't do anything. Oh, okay, I was hoping that you could advance the fill value as well. That would be kind of useful, but that's fine. That's fine. I wouldn't expect that to have worked, really. It just would have been nice if it had. Okay. The reason I wanted to do that is because I wanted to show you how you can use that to scroll the screen. So I was going to fill the screen with random stuff and then use Dma to scroll it. But I mean, we can do that anyway. So we'll keep this as it is for now, but we'll change this to 2 0 so it fills with spaces. So now that's a proper clear screen routine. So it's going to clear the screen and set it all to black. We can probably add that. I'm not sure how useful it would be. I mean, it might be. Actually, it might work for yeah, it could be. Yeah, it could be useful, I guess. I don't know though, because we've got to be careful that because it might be that the source step. Yeah, that's what I was thinking. It would be good for. Yeah, it could be useful for doing special types of fills on screen and stuff. Yeah, it'd be good to look at it. I wouldn't say it's a huge priority, but if it can happen, that'd be kind of nice, I guess. It's not a huge, but it's not a huge deal if it's not though. Okay, so what we're going to do, I'm just going to set up a very simple routine here. Actually, I can do it with X and Y, can't I? Because you've now got store both, right? So, in fact, I can just do it like this. So I think I can do. Oh no, I have to have both. Okay, never mind. I think I can do this though. But with Y, obviously. So all I'm trying to do here is just create some, not random junk, but some junk on the screen that I can. So there we go. We've got some stuff on the screen. So what I'm going to do now is I'm going to use Dma to shift this data, and you'll see how useful this is. So quite often, what you'll want to do is you'll want to scroll the screen. I'm not going to do left and right because left and right is slightly more involved. Actually, no. Let's do left and right because it's an interesting exercise in proper scroll. Yeah. All right. Let's do left and right. Okay. So if we want to scroll left and right, what do we need to do? Well, you could just say we just start here and we just copy whatever is in this byte into this byte and then advance and just go like that. So let's do that and let's take a look at what happens. So what we're going to do is we're going to set up in the loop here. We're just going to set up a very basic raster weight sort of thing. Um, so I think I've explained this before. It's good to just do 2 of these on the Mega65 because it's so quick. If you don't, you can end up doing things on one line and end up doing things more often than you want. So what we're going to do here is we're going to do a shift screen DMA, and we're going to try and shift the screen to the left, something which is kind of the bane of a C64 scrolling routine. It's the sort of thing that slows things right down, and we end up having to use tricks like VSP um, or other tricks to kind of do this in a very efficient kind of way. Um, Now, obviously, if you just scroll the screen data, you can do this on the C64 within a frame. It's only if you do screen and color data and you want to scroll the whole thing, an entire screen. So if you're scrolling 2,000 bytes, basically, then it becomes a problem. So this is going to be quite quick, but we're going to. Sorry, this is going to be possible on the C64. But what I am going to do is show you how much quicker it is by just doing a little border increment and decrement at the end around the DMA. So use the same setup, run DMA job, return, and then we'll set our job up here. And we need a DMA header. We could do color RAM scrolling as well, but it's not really much point. So um, our DMA header is 00. We're doing from screen RAM to screen RAM, so our pointer is always at the lower end here. Don't need to really do this in each side. It's obvious. I'm going to leave it here so you can see how to do bank calculations, but with screen RAM, we know it's correct. So then it's DMA copy job. And what do we want to do? We want to copy the data from 0801 backwards by 1 byte. So we say, let's go and have a look at the copy job. So we've got a source and a destination. So our source is 0801 and our destination is 0800. And we want to copy 999 bytes. We don't want to copy 1,000 because that's more than we need. 999 is fine. So we have a look in here, source, destination, length chain, and whether or not we do it backwards. 999 chain, no, and backwards, no. The backwards thing is interesting because what you can do instead is you could start at what would it be? OB E8, E7, sorry, like that. And work your way backwards, which if you're scrolling the other way, you will need to do. Um, Anybody who's done this kind of shifting of a data in an array will know you have to go backwards or forwards depending on which way you're shifting the data. Same concept here. So let's have a quick look at that and see what happens. It's probably going to be very quick, this, so it's probably going to be too quick, actually. So there you go. You can see it moving, but you can see what's happening is it's not filling in the data correctly on this side. So it's scrolling across, but then it's being replaced by junk at the bottom here. So what we need to do is we actually need to copy. Let me just start it again without the DMA on so you can see what's going on. And you can see how quick that's happening. Look at the line at the bottom. It's happening almost instantaneously. It's very quick indeed. So what we need to do is before we shift it, we need to take a copy of this column here. And then once it's shifted, we need to paste that column over here. Very easy to do. So what we're going to do is we're going to set up, we've got our job here, and we're going to set up a temp column here. And I'm just going to fill this with 25 bytes, 0. It doesn't really matter what we fill it with. And we're going to change some jobs here. So what we're going to do is we're going to do a copy job. And we're going to copy from 0800 800 to temp column. and we want 25 bytes, and we do want it to chain. But we need this to step differently. So what we're going to do is we're going to do a step here. Oh, I got itchy nose. And our step is going to be, our source is going to change 40 at a time, no fractional value, but our destination is just going to be 1 at a time. So we're going to take a character from the first, from the beginning of the first row, and we're going to put it into the, put it into the temp thing here. And then we need to do another header because we're going to chain this job, which is going to shift the entire screen across, which is this one here. By default, the step should be 10101, 1010 now, sorry. So we don't need to include that here. It shouldn't matter. It should hopefully be fit. Actually, this is a good test because I've never actually done it like this, so it would be interesting to see if this works. And then we need this to chain as well. So we need to put true into the chain. And then we need to do another copy here. This time our source is going to be temp column and our destination is going to be 0827, which is the very far right of the screen. And that means our steps need to switch over. So destination step of 40, a source step of 1. And this will be the last one in the chain. Oh, and another header. Thank you, monsters. I think that's. I'm going to give monsters points for that. I feel like I'm not giving out enough points at the moment, so there we go. Cool. So that should, in theory, copy that column on the left hand side, shift the entire screen over by 1, and then copy that column back on the right hand side, and it should do it all very, very quickly indeed. Let's give that a quick try. Where steps till you fall asleep again? Oh, it helps if I actually run the job in the thing. Not running it, so here we go. Oh, what's going wrong there? Something is breaking. What have I done wrong? Hang on. Source temp, yep. What have I done wrong here? Maybe this does need. I think this actually needs this in. In which case, I am going to make sure that is always. If you use step, it always puts it in. It's kind of annoying, but because I think it's going to break if I don't do that. So that's interesting because I wasn't sure if that was going to happen. So if this works now, then I just need to adjust this. I think that's probably that's probably going to be the thing. Yeah, how is everybody getting on with Milfork then at the moment? It seems like quite a few people getting involved with it, which is kind of cool. Oh, thanks for the host, by the way, Prow7 and Sinlau. Completely missed that. It is, my alert volume is a little bit low, I think, but it's fine. I'll cope with it. I just need to listen out a little bit more, I think. So yeah, there you go. So I do need to get rid of these. So I will update these macros at some point. I unfortunately I can't spend quite as much time tomorrow on Mega65 stuff because I'm back at work. I've been off work for the past 4 days, 4 work days. So it's been easy for me to do stuff, but tomorrow I'm not. So it might be a little bit later on. I'll try and get it done at lunchtime, but I will update the macros with the stuff that we're doing here. It runs currently programming. Okay, cool. Yeah, I mean you've got like 3.5 weeks or so. It's quite a long time on it. I deliberately kind of let the thing leak over a little bit into July. Also to give me some time to actually prepare the next challenge, because the next challenge is going to be a bit more work from my side. I think the kind of basic bootstrap code, I like the word bootstrap now, I'm going to overuse it, I know it, is going to stay roughly the same with the cycle counter and stuff. but there is some other intricacies that I need to sort out that are a bit different to normal. So um, we shall see. I think you'll like it though. It's going to be very heavily algorithm based. So this is going to be less about the optimization. I think will matter obviously because it is still going to be cycle bytes, mega cycle bytes that you measure this challenge in. However, there are going to be so many different ways to do this. It's not like the kaleidoscope or the letters or the spiral where there's two, three, four maybe ways of doing things. Um, and some ways are obviously the fastest. There could be 15, 20, 30, 40 ways of doing this particular thing. So it's going to very much rely on thinking about the algorithm. Um, but it should be real world usable code as well. Unlike the other three challenges, this is something that you could actually use in real code. So you never know, we may see some games based on it at some point. I don't know. Anyway, there you go. You can see the DMA working now, and you can see that it's using maybe 2 or 3 raster lines. I think it's only 2 actually, less than 2 in fact, to do this. So very, very quick. A star. No, 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 no. Although that's a nice challenge as well. I've actually got a 6502 A star algorithm that I wrote for well, it's more of a Dijkstra. I don't know how to say that name. It's more of a Dijkstra's algorithm, which is a kind of A star is a kind of type of that. So yeah, does this work in Xemia? Let's take a look. Actually, let's open the right window. Dijkstra. Yeah, Dijkstra's algorithm. Yeah, so there you go. It does work. This is pretty cool. So anyway, this is the very basics of DMA. It allows you to very, very quickly copy data around. You can see we're doing stuff that would be generally be quite a difficult thing to do in the C64 in any kind of reasonable um, a reasonable amount of time. But now we're doing it in 2 raster lines. Bear in mind as well that the emulator will only ever do things based on an entire line. So subline kind of accuracy is not going to happen, which is why we see 2 full lines of color here. The advantage of that is it means all your rasters are going to be stable. If you change the color of a line, it's going to be the entire line that colors. You'll never get flickery kind of lines at the edges, which can be a bit annoying if you're trying to do something very kind of specific and you want to time it so that it's that your raster bars are perfect. It probably won't be on the real hardware. But yeah, there you go. That's that working. So what we're going to do now is we're going to step it up a little bit. So what we're going to do is we're going to create some data in a screen that we're going to copy. So we're going to take the data that we've got here, and we're going to actually instead of doing it here, we'll get rid of the shift screen eventually. What we're going to do is we're going to put some data down here. So I'm going to call it screen data, and we're just going to fill this with some data. So we're going to do some loops. Actually, let's just do this really simply. All right, so I will do this. We will just do yeah, for r equals 0, r is less than 25, r plus plus. And then we'll do the same with columns. So we want 25 rows, 40 columns. And we're going to have a value here. It's going to start on 160. And what we're going to do is we're going to put that byte in there. So it's going to be 160. So if I just did this, it would just fill the screen with inverse characters. But what I want to do is after each time I do this, I want to do eval char equals char exclusively ored with let's get this right. What would it be? It would be, I think, 128. There we go. Should do it. And that will toggle between solid like a reverse character and a blank character. And then what I'm going to do is after each row, so once all the columns are done, I'm just going to do that again. And now we're going to write a job that's going to copy this data now into the screen. So we're going to change this and we're going to call it copy screen DMA. So let's just put that in there for now. We'll actually change this in various ways shortly, but we'll keep it in the loop so you can see what we're going to do. So we'll get rid of. Actually, let me keep that so you can use that as a reference somewhere. So let me put that down here. I'll keep all the DMA jobs that I create so that you can reference them later rather than get rid of them. So. Okay, so this is going to be a really simple one. Okay, and our job is going to be super simple. DMA header, we're copying from here, which is going to be in the lower bank of memory. Yeah, and it's very much appreciated as well, Monsters. Very, very appreciated. We wouldn't be able to do this competition without that kind of help. And I want to thank FaZe in advance for similar help, Prince FaZe, in August when we do the TRSE challenge, which is going to be the same sort of thing but using TRSE to generate some stuff. I don't know what the challenge is. It is another game. It's making a game but using Milfork. So it should be kind of interesting. Take influence from cassette 50 games. Yeah, it doesn't have to be a cassette 50 game. It's just a kind of a general suggestion that it would be a good idea if you did a cassette 50 game. I definitely think if you've entered the cassette 50 competition, it's probably worth having a go at this because the games tend to produce less entrants than the optimization challenges, generally because I think they need a little bit more time spent on them. Although I reckon people spend more time on the optimization challenges in the long run anyway. And they're also completely make Cosmic Force but gooder. You mean just make any game? Yeah, people tend not to join the game one as much, and it's a shame because the game one is just a prize draw. So all you have to do is enter, and you're in with a chance of winning. There's no judging of the game whatsoever. It's just as long as it fits the criteria, and it's considered a game, then that's good enough. Mega65 Milfork, yes, yeah, and the emulator is now in a state where it's actually much better as well. So we've got Turrican running in it. We've got Luma running in it. I'll show you in a minute, actually, Luma and that running in it. And Toxic Frenzy starts in it, but it crashes when you start the game. So I'm not sure what's going on there, but you can definitely get things to run in the emulator now, but much more than you could do previously. So. But don't worry, anything that doesn't run in the emulator at the moment will eventually be will be fixed. That's my aim anyway. Okay, so let's set this job up. So DMA header, we just want to copy the screen data. So it's called screen data, nice and easy. We want a DMA copy job. Copy job. and our source is screen data. Our destination is 0800. Our size is 1000. We do not want to chain, and we do not want to do it backwards. It doesn't really matter if we go backwards or forwards here. So let's do that, and hopefully we should see the pattern that I've generated. All's gone well. And there we go. We have a checkerboard pattern. Okay. What I'm very quickly going to do is I'm just going to show you some stuff running in this. So first of all, let's go through the Millfork stuff very quickly. So I spent this week trying to get the Millfork stuff to work in. Oh my god, it's not drag and drop, is it? Well, it is drag and drop. I'm not actually drag and dropping. Getting the Millfork stuff to run in the emulator, and you can see there it is. It is running now. So it's a 16 color demo. You can see that working there. The DMA test. You can see that's copying data correctly around the screen. IRQ test is doing strange things. I sometimes get this to work and sometimes don't. I'm not entirely sure what's going on with this. But needless to say, IRQs do work. I don't know why they... Yeah, see, there you go. Drag and drop doesn't always work the same way, so that's interesting to know. Raster rewrite buffer stuff. So this was a big one. There was quite a lot wrong with this. From alternate palette stuff wasn't quite working. The sprites were disappearing as they went off the edge here because of the negative RRB kind of expositions. And the horizontal flip of 16 color characters wasn't working, but now that's working as well. There is a slight blue tinge down one side. Same happens on Turrican, as I'll show you in a minute, but it's pretty much close enough. And then the sprite test as well, which actually works better than the hardware. There is a bug in the hardware, which I've reported today and created a test for, which Monsters found, which is after 128 rows, the sprites don't repeat properly. Any idea you got Millfork syntax going on? I believe there is a syntax file somewhere for it, which should be compatible with both VS Code and Sublime. I believe you can use VS Code syntax files in Sublime. I think it's a standard format. So that's that. Let me show you if I got Turrican demo. I have. Why did that load? Oh, because I need to reset. Oh, why is it not working there? What? Oh, am I using an old? I think I'm using an old. Yeah, I'm using an old version. Hang on. Have I got the latest version? I haven't. All right, let me just open the latest version. For the easiest way of doing it. So that's what it used to look like. It's gonna look. It's gonna look very wrong on the. So you can see when the disk isn't loading, that's what it looks like on the real hardware. We can see on the emulator, it is now working. So you've got you got Turrican working on here now as well, which is kind of cool. There are some bugs. There seems to be some issue with the right hand side of the screen here, and some stuff. I think it's raster rewrite buffer stuff going off the screen over here. But this has come along a lot. I mean, this didn't work at all, and now it's working. So that's kind of cool. And then there's also Luma, which should. Oh wait, is this the? This isn't Luma 65, is it? Hang on. There we go. Yeah, I did see the Turrican Terminator. I'm not sure what to make of it, to be honest. I think Turrican is a very hard game to get correct, to be honest. So this mostly works. I've noticed that there are some strips of the head-up display missing. I'm not sure why. It's something I'm going to look into as well very soon. I don't know what's causing that, but I shall investigate. But you can actually play the game now, so yeah, so it's kind of cool. This actually all works now in Xemia, and this is why I've been working really hard with LGB and Hanan to get this working. There's obviously there's still issues with things. Sound is a big one. Sound is going to be take a while to get right. There is some rudimentary sound there, but it's not great. So we need to do some work on that. I think LGB's been looking at that a little bit today, but I don't think that's a huge priority. So good night, Quadrisaur. Thanks for joining. But yeah, that's I mean, basically there is no reason not to be writing stuff now. Certainly everything you write, to be fair, all the games that have been written to this point have worked well in Xemu anyway. And I've got the wrong file open. I'm gonna hang on. That one wasn't it yet. I suppose that one. So things like Mega Dots and Cali Cloak or whatever it was called, I can't remember how to pronounce that properly. Hit Block, things like that. They were all, these are all games that worked in Xemu, but now it's even better. So now you can do more. You can use floppy code. You can use the raster rewrite buffer properly. Sprites kind of behave how you expect them to behave mostly. There's a few little issues here and there, but that's what these competitions are about. So please do join the Milfort competition. Pick something simple if you don't want to spend too much time on it, and just have a go. Just have a go at something and see what you come up with. I think you'll be pleasantly surprised at how much better the emulator is if you use the merger branch, and it is continuing to improve. LGB and Anand are working very hard on it. I'm trying to get as many bugs reported and even fix some of the bugs myself if I can. So the comp started on Saturday. It runs through to the 2nd of July, I think midnight on the 2nd of July. So basically the day before the July the 3rd stream. So it gives you about 4 weeks from last Saturday. And with it being a mid-level language, you should be able to take code from like from the cassette 50 and do a pretty easy port. I would think. The only stipulation is that you have to use at least one Mega65 feature that isn't available on the Commodore 64. So that could be like high color mode or using raster rewrite buffer or 16 color sprites, something that just makes it stand out as something that's more than a Commodore 64 game. Okay, so let's continue with this. So again, what I was doing, I was just putting this pattern on the screen. So what I'm doing to do this is I'm creating this pattern in memory, not in the screen. This is created down here. And then I'm copying it to the screen with this routine here, this copy screen DMA. Now at the moment it's doing it every single frame, and there isn't really a huge point to that. However, if I was to change some stuff in here, say I was to add a DMA step in here, and when I'm reading the data, I'm going to read less than 1 byte at a time. I'm going to use fractional DMA here. So I'm going to step half a byte at a time. So 0.128 if you want to talk in kind of, let's do it like this. And then you can see it's kind of, this is our integer, this is our fraction. And then on the screen, I'm gonna on the destination, I'm gonna keep a destination of 1. Oops, I just closed that file. I didn't want to. So you think, okay, what is this going to do? So what this is going to do is it's going to, when it's advancing the counter, it's going to advance the source counter like so, right? So this is our source, and this is our destination. So they both start at 0 with a fractional of 0. New series. What is it? Oh, okay, cool. New series. Can you guess what that is then? I think it's kind of obvious what that one might be, but it's a big one. This is a courtesy of, oh God, I forgot who did this. Oh, was it? Hang on. Yeah, it was Cod. He's gone as well now, which is a shame. Uh, yeah, it was. It was Quadrasul who did this one. Yeah. Ah, man, that's a shame. So yeah, our source starts here. Let's write source here, and our destination starts here. So when it goes to read the byte, it's only going to use this integer, read and write, but it has this fractional value that it's going to keep using as well. So what it does is going to read from byte 0 and paste to byte 0, byte offset 0, and paste that to byte offset 0. And then when it steps, it's going to step this like so. Let's do it with hex on here. So it's going to add 0080, 0080. So now we're still at byte 0, offset 0, but this one is now at byte 1. So now we're going to copy byte offset 0 again to byte offset 1. And it's going to keep repeating that as we go through here. Now, what that's going to do is on the next byte, it's going to go 100, 200. So now it's going to copy byte offset 1 to 2, and then byte offset 180 to 3. And you see what it's doing? It's copying each byte twice. Do it like 0080 in the comments. Oh yeah, like that. Yeah, that makes sense, doesn't it? Anyway, I'm not gonna leave that in there, but yeah. BT Mr. Humphreys. Oh, okay. But yeah, that's not a bad idea. I know how to do it. Anyway, let's try this out. So what this is going to do is it's going to copy things 2 bytes at a time to the screen. See what happens. And there we've got a grid that's zoomed in a little bit. Now, this is only going to work if we do things in nice steps. If we do everything in steps of multiples of 2, this is going to work well. So if I do like that, it's going to be 4 times as big. Like so. If I do it like that, it's going to be 16 times as big. Oh, no, it's not actually. Why is it not? That is because because we've actually reached the point at which. So the reason why this only works on certain sizes is because what happens when we get to the very edge of the screen, we're still reading the data from the screen on that particular row. So what we'd actually have to do instead is we'd actually have to change our to make this scale at any point that we want. We'd have to do this in copy screen Dma job plus 6. Wait, what? Dma dot job plus 6. Header 1, 2, 3, 4, 5, 6. Oh, this one here. Wait, what? Copy Dma job 0, 1, 2, 3, 4, 5, 6. Oh, with that on there. Yeah, but Oh yeah, so we can see what happens. Ah, I see what you're saying. Okay, you mean this value here. So that's 0, 1, 2, 3, 3 plus 3. Okay. Okay, yeah, so let's do that. So if we set this to it doesn't really matter what we set it to. Let's just do it like this. So actually let's so what we can do is we can do source actually can I do this here? I think I can I? If I do label source frac step equals start plus 0, because that's this one here. And then we should be able to do that. There we go. Just have that in. It looks weird when it's over there. Oh, that hasn't worked though. Why hasn't that worked? Oh, I think it's overwriting somewhere. Source step, destination step. Source step fractional. That should be right there. Let's try again. I think it's +2. Oh, it looks really weird on that screen for some reason. Let's close everything. Hang up. That should be so. DMA step is just. Oh yeah, sorry, I'm miscounting the bytes, aren't I? Oh, it's +1. That's why. It's this one +1. I'm miscounting the bytes in it. That's why. I was just looking at this. I was completely ignoring that. I was treating that like a comment. There we go. Problem is the main machine's locked up there, so just turn that off. So what we're doing now is we're gonna yeah, it was pointing at 82. Yeah, I'm gonna give you more points there because you pointed me in the right direction, definitely. And I just wanted an excuse to give more points out. There we go. So you can see what's happening there. We're zooming in on the data, but as we're zooming in, obviously things are kind of offsetting a little bit weird. So to make this work properly, what we need to do is we need to think about it the other way around, or this is the easiest way to think about it, in my opinion, anyway. And instead, what we're going to do is we're going to draw each row one at a time, but we're going to use each row to figure out where we should be pulling the data from. I think that's the right way of doing it. Hang on, let me think about this. But you can see it's working the same on both. So let's put 0, 1, 2, 3, 4, 5. Okay, so then source step would be +3. Destination step is +7. So now we've got labels set up for all of these. And what we'll do is we'll do one row at a time. So I'm learning this as we go along. I want to say I understand the concept behind this. I understand the roughly the algorithm that goes behind this, but I've never done this before, so it should be interesting. So we want to do this 40 times, 25 times, one for each row. So we're gonna do this DMA job 25 times. So we're gonna set a loop up. We will go from 0 upwards. I don't think there's any need to do this backwards at the moment, just so I can keep this kind of working correct in my head. Now, every time we run this DMA job, we need to change something on here. So we're going to change these values here, but we're also going to change the destination and the source as well. So we need to set those up as well. So let's go and take a look at our copy job and work out where those are. So we want source low and source high, and destination low and destination high. Hopefully you can see that okay. And we only want to copy 40 bytes at a time now. So we're just doing one strip across the screen and we're going to copy it. And these values are copy job. Okay, so 0, 1, this is not set. 2, 3. So this is, let's put some notes in here. Byte 04, 05, 06, and then byte 07. Okay, so our source low is 4. That means our source high is 5. And our destination low is 7. And our destination high is 8. So there we go. We've got all the things we need now to set this up. So what do we want to do? We want to copy for each row. We want to copy from the source data. Actually, let me think about this. Hang on. Yeah, okay. So we need, we probably also need here rows, which I'm going to fill 25 times high and low, which is going to be rows low. I'm hoping I get time to show how you can do. I should have probably done line drawing first, actually, because line drawing is a bit simpler than this. So we go. We've got high and low rows, and we need to grab those from our row counter, which is going to be 2 bytes high and a low here, right? So first of all, we're going to reset the row counter. So we're going to actually can do well. I'll do it here anyway. Could just reuse that, but so we're going to have our own fractional row counter, which is going to count down the screen as we go. And we're going to use that to set our destination. So we're going to, first of all, we're going to grab row. This is basically fractional as well here. So we're going to increment. This is our fractional. Let's write here frac and integer. So we're going to load y with row counter +1. Load accumulator with row high, rows low, comma y. Store that in. Is your BG Mr. Men series case sensitive, Mr. Bumpton? No, case sensitive should not matter at all. Let me move this up here and just double check for you. But case, I don't think matters. It shouldn't matter anyway. Oh, Mr. Bump is. Oh, maybe it is case sensitive because these are actually do have uppercase in them for some reason. Hang on. I could have sworn I tried this though and it didn't matter. So let me just check. Or maybe I don't have them all in. Oh god damn, that's annoying. All right, just for now, type the Mr. Men with uppercase M and uppercase name. See if they work. God damn it, I have to fix that. All right, minor issue though, minor issue. Or just don't do Mr. Men just yet. Wait until next time. I'll fix that. I'll make a note to fix that. Yeah, so just a note there. If you do supply backgrounds, please supply them all in lowercase. I didn't think this was an issue though. I thought I tested this, but obviously it seems to not work in OBS for some reason. Or you're just being too slow with it, maybe. I'm not sure. Uh, in 7 years, one female cat, one on his second after. What? That's bullshit. That's bullshit. Oh, mind you, I guess cat. Actually, yeah. I don't know. I don't know whether to believe that. Okay. Blah, blah, blah. Forgetting where I am now. This is a problem with all these things. How many instructions does this thing have? 256. All of the instructions are used, basically. I mean, 256, you include all the different addressing modes as well, so... It's not working, is it? I don't know why it's not working. I would ignore the Mr. Men one for now, or something is broken. I don't know what's going on with that. But I'm gonna stop thinking about that, or else I'm gonna forget where I'm at. Okay, so destination low. Destination high. Okay, so that's our destination row. And that's going to increment as we go through. So every time we run the DMA job and move on to the next line, we're going to increment our value in here. So we're going to also have in here, actually, let's put it, yeah, let's have it here. Okay, so so scale factor is 0. So this is the default 0, 1, 0, 0. And we'll change these values on the fly through this. So when we get to this point here, we need to take our row counter was 0. We need to add scale factor. Actually, this should probably be the other way around. Like that. Little endian. Let's keep the little endian stuff going all the time. You want to do the fractional position update on the source, not the destination. Oh yeah, sorry, yeah, the rows need to go down. Sorry, I don't know what I'm thinking. Yeah, I'm not thinking right, am I? Hang on. Let's do this in a second. Yeah, okay. So source. Yeah, you're right. Sorry. And this should be, oh, it's high and low. Destination steps plus 40 every time. Yep. Yeah. God, it's so confusing trying to do everything all at once. My God. This is the hard thing about doing these streams. It is really difficult to do. Okay, right. So that means this actually needs to point not to screen RAM, but to screen data. Oh, actually, no, we do need these as well. Oh, no, we don't. That's just going to increment by 40 each time. Okay, there we go. There we go. Right. So now we need to take our row factor and we need to add. So this is, I'm going to write in here, increment source data row. And we'll just do this the simple way. There we go. Heckling, yeah. uh, there we go. Right, okay. Dun, 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 dun. Okay, so we are incrementing our row counter and we're running this DMA job. So if we run this now, what we should get, actually, what we'll get is just one row. We won't get multiple rows. So what we now need to do is we do need to increment. We need to set our destination. So, oh, also we need to include. Oh no, it's already labeled here. So destination low and destination high. Okay. So destination low. Actually, let's so it's obvious what we're doing here. Screen RAM. Okay. Then after each row, we also need to increment destination row. So I'm just going to copy this, pretty much the same stuff, but this time we're incrementing destination low and destination high, and we're adding exactly 40 each time. God, see what I mean about typing? I can't type properly at all. So yeah, as Monster says, what's happening here is we go to draw a single row. We start our row counter in the data, pointing at the same place. Then as we move down the screen, we always move one row down in terms of target, but our source can move fractionally through the data. And in fact, this should be enough now, I think. Dma step, destination step. Yes. So we just keep the step the same for now. You should see that this vertically will actually scale if we do the increment as well. So if we just change this scale factor here. I mean, at the moment, this is just going to change one small part of it, but we should hopefully see something. Oh, why is it not running on the main? There's an error here somewhere. Row counter. Did I not call it row counter? What did I call it? There we go. So the problem is wait, hang on, that can't be right. That can't be right. What's going on? Okay, so if I don't do that, this should. Let's have a look. Copy row counter 0, 0. What have I done wrong here? This looks good so far. Add 0. Scale factor is only 8-bit. Yeah, I'm adding this. I'm just incrementing this value here at the moment. I'm ignoring the fractional. I'm just incrementing the incrementing this value here, and it should be taking that value. Oh, that's right. This should be scale factor plus. Oh yeah. Sorry, I'm being stupid. That's why. There we go. Do you know what? More points for Monsters again. Monsters is catching you up. Thank you for the follow, Yasinan. However you say your name, welcome. And thank you for the follow. Cheers. Oh, I need more cider. Oh, they do work. Oh, okay. Okay, so now the scale factor is correct. So now if I just increment the upper value. Cheers. Oh, wait, hang on. This is because scale factor is not actually. Hang on. This is doing. Hang on. It's scale factor is incrementing our source data. Oh, so we're only getting a couple of rows correctly, and then it's skipping over. So actually, we need to go down. If anything, we need to change. We need to change the fractional value down here. So it's inverse, isn't it? So if I do that and change that value, it will. Yeah, it's because I'm thinking about the scale from the wrong direction. So it's actually inverse scale. It's 1 over the scale. So we're zooming out there rather than zooming in. There you go. So now you can see it's trying to do the zoom in and out a little bit better. But now we're only doing it in the vertical direction here. You can see it runs into some problems when the values don't quite kind of fit neatly within an integer. So but you can see it is actually crunching things down vertically like that. So now if we want to do the same thing with the horizontal as well, we can just change the destination, no, the source step and source fractional step here as well. And that's all we need to do here. So we just do that here. So we're going to take these things here. So we're going to load a value and store it in that, and load a value and store it in here. And that value is that. Oh my God, I got there in the end. So there you go. You can see now we're kind of zooming in. So it does have some issues when you get to certain kind of zoom levels. Then it's just because it's skipping over. It's well, not skipping over, but it's not. The numbers don't divide nicely, so you end up with something that doesn't quite fit, especially when you're in small. Now we're doing this on a character scale here. Obviously, if you do this on a pixel scale, then things will work a lot smoother. You'll be able to do this with an entire image. I wish I had an image set up for this actually, because we could do it. The only difference is with an image is you need to do this in vertical strips instead of horizontal. So at the moment we're doing it horizontally. With an image, you would need to do it vertically. And the reason for that is because if you look at an image in the Mega65, what you get is you get 8 bytes in a row like that, and then because it's character based, you get another 8 bytes here, and then another 8 bytes here. So you have to go down 8 rows before you come to here. So in order to increase in the X direction, you have to add one, add one, add one, and then every 8 you have to add 64. So it becomes really awkward. But if you do things in vertical strips instead, then what you get is you get one character here. So basically, this is the normal way you think about screens, right? With our characters numbered left to right like that. But as I say, what that means is you've got 64 bytes in this location, which cover 8 rows and 8 columns, and then you move across to here. But if you do your strips like this instead, then what you have is you have 8 pixels in this direction, and then you come back again. But if you think about the Y direction, you always just add 8. If you just add 8 to your offset, you'll always go down 1 row. So that means you can go all the way down the screen just by stepping 8 bytes at a time. So if you do that across the entire screen and you take vertical strips, it's nice and easy. And really, it's just flipping these things around and doing it the other way around. I wish I had something to do this, like an image that I could do. Unfortunately, I don't have anything set up with the vertical strips. I might do that for Saturday. Actually, I think what we'll do on Saturday is we'll take this DMA routine one step further, and we'll start doing it with images. But the other cool thing you can do with this as well is you can do this. You can rotate things like this as well. So if you imagine you've got a line that goes like this, right? Then your step is quite simple, right? Your step is every time I'm moving across this line, my step is going x plus 1, my y is plus 0. But what you can do, oh, it's very faint now. Let me just knock that up ever so slightly. There we go. Thank you very much, Def, for the bits. Appreciated. Hey, old school coder. Yeah, the backgrounds, the Mr. Men backgrounds aren't working properly, so you will have to wait on those ones, unfortunately. They need to be lowercase and they're not, so I need to go in and fix those. I thought it didn't matter, but obviously it does. So it's a bit frustrating. It's probably I need to find out why that is the case. So I can figure it out. It's fine. But yeah, it's a bit annoying that is happening. So, oh, thank you, Warlock. Thank you for the follow, Priyansh4610. Welcome to the stream. Hope you're doing well. So yeah, if you've got a line that's a straight line, then you can just step like this. But if you rotate this line, then what you're doing is you're basically just changing the step of the line. So if I do this, for instance, whoops, one more there. All I've done is I've just changed the step of the line. So I'm using fractional values here to say for every 3, so I'm going to advance the y 1/3 and the x by 1. So I'm just using fractional values, and you see that fits neatly into what we're doing with the DMA. So you can do the same thing. So what you can do is you can say, I've got an image here, and this is the data in the image. But what I want to do is I want to rotate it. So I'm going to work out what my steps are. I'm going to work out what my X and my Y step are. You could create a table for that, or you could probably use the math instruction to do that, or the math unit to do that. And then you just basically you change the destination. So, and now you've got this same image, but it's rotated. And if you do that for every row in the image, you will get a rotated image. Now, the proper way to do this, I think, is to work out the bounding box of this image here and do this in strips. So once you know where you are, you do it in strips. You say, I want to do this strip down here. Where does this? And you do the step actually through this instead. So you work out where you are here, and you work out if I go down one row, where am I going in this? You work out the step through the image instead. And then that way it draws properly. Because if you do it the other way around, you'll end up with holes in it and stuff. But if you do it this way around, where you do this strip and you work out what goes where in this strip by advancing through the image data, you should be able to create something which will rotate smoothly a texture. And because you've got full color modes, you've got no color restrictions, you should be able to do that very, very smoothly. Always fractional step the source data, yeah. And yeah, as Monster said, if you fractional step the source data, you avoid the holes then. So because what you want to do is this is where the term in 3D graphics, you still have what's called a rasterization process. And that's basically what the rasterization process is doing. The rasterization process says, given a triangle, say this is my texture, and my texture looks like this. Probably with a bit more variation, but you get the point, right? This is my texture. And I've got this triangle, and it starts at this point here, and there's another point here, and there's another point here. The rasterization process basically says we start at whatever a given point, like on the, it's usually the top, I think. I'm not entirely sure, and it just works out where in this, if this triangle has this texture on it, or like a a segment of this texture. It would be something like this, right? This is what it's trying to draw onto this triangle. Right, so that's what it's trying to draw on here. It says, okay, what do I need to draw at this point? Where am I? So it starts here and it goes, go all the way across until you finish drawing that piece of the triangle. So in this case, it would just draw one thing. Then go on to the next line, work out where I am in here, and draw a line straight across and work out what the step is through the texture in here. And that's basically how rasterization is working. I mean, obviously we have hardware to do this very quickly on modern machines. That's what your graphics card is extremely good at doing. But it's essentially how it kind of works. It actually interpolates the values between various points. So it knows where you're starting and where you're ending, and it works out the interpolation between those. Um, Also, graphics cards do some clever stuff as well, where if so you can see when this checkerboard gets really, really small, we start getting weird kind of glitches in it. And those glitches are because things don't quite divide correctly into nice even numbers. So you see this kind of weird pattern appear, like another checkerboard within a checkerboard appear. On a proper graphics card, what will happen is if a value is not exactly on an integer and it's somewhere in between, it will interpolate between those two values. So what that means is if something is black on one, a black pixel here and a white pixel here, and you're somewhere in the middle, it will pick a value between black and white, which will be like a gray color. This is called filtering, and there's lots of different types of filtering, various kinds. Um, I think the most common one you're probably used to seeing is bilinear and trilinear filtering, but there's other kinds as well. That can actually be used for some clever stuff as well. So filtering is a really good way of doing vector style. So there's a thing called sign distance field fonts. I'm going off topic a little bit here. Sign distance field fonts is where you take a very, very small bitmap font and you use a trick in a shader that uses the filtering to actually draw either a solid pixel or not a pixel, and it creates, you can scale in, much like we're doing here, you can scale in and out, and you can create some very, very sharp kind of font edges around things. Very, very, very powerful thing. Science did, yeah, we're off on a journey. Yeah, that was a bit of a tangent, but it's I really like that side of 3D graphics. It's kind of cool. Okay, so what we'll do is we'll stop this one now, and I'll show you how to use fractional steps to draw a line basically now, right? So let's do another one here. Let's call it, let's just get rid of that for a second. Actually, let's just comment that out. So and let's do a line draw DMA. And let's just run that so it stops doing that flashing thing. It's driving me mad. Oh, it's completely turned off now. That's weird. Oh no, it hasn't turned off. It's a blank screen, isn't it? Of course it's going to do that. I'm an idiot. My brain's not working properly after the cider. Anyway, right. After going on a tangent about rasterization and stuff, let's actually look at some more stuff. So what we're going to do this time is we are going to we'll create another DMA, but this time we're going to draw a line. So what we're going to do is we're going to run Dma Job. Again, we're just doing this in screen space, but you can in char space, but you can do this at the pixel level. And once I think what we'll do at the weekend is I'll set some images up and stuff so that we can actually start messing with things in that way. We can do something that's that's designed in the right format so that we can kind of play around with rotation and stuff. Rotating will be tricky, but we can. I definitely think we can do it. I'm pleased that worked, to be honest. Thank you for the follow, JKS Kado. Welcome to the stream. I don't know if that's supposed to be said out loud or if it's or if it is an acronym. So I certainly can't pronounce it if it's a pronounceable name. Oops, I had the right screen up. Okay, right. So this time we're just going to draw a line. So we're going to need a DMA header again. And this time we're going to use a fill job. And what we're going to fill. So we're going to fill, we're going to put the byte 160 on the screen. And we're going to start at 0800. So we're going to start in the top corner. And we'll draw, let's draw 40 across, right? Not chaining. I should have done this one first. This is going to be a lot easier. So any info on setting up Milfork and Xemu's latest builds are broken. You should use the merger build. That's the build that you should be using. If you go to the Xemu download page, the very one at the bottom is called merger. It should have the most recent update. It's the one I'm using here. Merger is broken. Oh. Oh. It exits before you can do anything. Let me double check that because if that's the case, I need to let LGB know. Let me find the right download page. Where's the download page? There we go. Zipped 64-bit Windows binaries. We save that, open it. Okay, so let me just copy all these over to the right folder. Where is it? Xemu. Where have you gone? Where have you gone? There you are. Okay, let me just back these up just in case it does break, and then I've got something to work with. Oh, that's weird because I shouldn't have done that. No, let me do it that way. There we go. Just in case it does break, and then I've got something I can return to. Oops. How to buy. I'm pretty sure whenever you click that how to buy button, somebody at WinRAR HQ gets really, really excited. We've got one. There we go. Oh, it does indeed crash. Okay. Okay, cool. Let me. Okay, let me just send a message to LGB about that. So. Where is it? Oh God, where's my? There we go. There we go. So just let him know that that's crashing. I will, if somebody can drop actually, I can drop my version in. So all you really need is Mega65.exe. I will zip that up now and I will drop it into the channel. So let me drop that in the Discord and then you've got something. So apologies for the delay, guys. So while I get this sent. So if you just go into Mega65, get excited. And there's the Windows build. Oh, you've done it already. Okay, cool. This is my build from today. So this should have all the latest changes in up to today. And that's just that file. I don't think it's got the SDL changes in there, so you might get an SDL warning at the beginning, but it should still run fine. But thank you, Andy, anyway, if that works. The other one doesn't, so okay, cool. I'll leave that there for LGB to try and fix. It could be nothing. It could just be some weird build issue. I've not had any problems building the code that was built today. So unless he's made another change since then, which I can actually check if I just do. Actually, I'll do that later. I'm not going to do it now. Okay, right. So back to this. So we're going to do a fill job. We're just going to. So let's just run this now, and we should see just a line across the screen. We've got an error. Dma fill job invalid. Oh, valid number arguments because we don't need to go backwards on this. It's just a chain. That works. Cool. Why is it not drawn? Oh, because I haven't actually called it. Let me call the function. So it's a very simple checkerboard scale. That's not like you would see on demos or anything. So there we go. We're just drawing a simple line across the screen. So at the moment, this isn't doing anything unusual. We're used to seeing this kind of thing. But if we were to change the step again and to do something a little bit different, so we're going to change our source. Sorry, no, we're going to. Yeah, source is going to remain the same because this is a fill. And here we're just going to change how often we go down. So if you were to make this super steep, then it would break, and we'd have to do this in a slightly different way. But up until the 45-degree angle, we can step fractionally. So if we were to step, actually, shit, is this going to work? No, this isn't going to work, is it? Hang on, let me think about this. No, this is not going to work, is it? Okay. I actually think Paul added a line DMA into. Actually, let me check that. I think he added something for this. DMA. Yeah, I seem to vaguely remember that being something that was put in. It's not in here though. Where? I know it's got spiral in it, believe it or not. That'd be really good if we can find that and see if that works as well. Oh, maybe it's not in here. Not seeing it here. There should be a job type somewhere, and it's, you know, I know he's put my name in it as well, so yeah. So it's not. I've not got it in that chipset reference. All right. Just trying to think how you would do the line then, because I thought this was going to work, but it's not. I guess we have to base on lines going down the screen. No, it's because yeah. So actually, line DMA needs its own thing. Okay, that's fine. That's fine. I mean, this is going to be the same as doing a rotation, pretty much. Page 6. I don't have the full thing though. Sorry, at the moment. Oh, I guess I could go to the page. Can I? Hang on. Oh, is that on the full book? Okay, let me get the Mega65 book. Let's just download the latest PDF, wherever that is. God, damn it, where's the main? Uh, where's the pre-builts? There's usually some pre-built stuff. Ah, there we go. Pre-built. Show me them all. Book. There we go. No, it's removed it. Okay, let's see if Spiral is in there. No, it's not. Maybe this isn't up to date. Oh, Death sent on from. Okay, let's try that one. Shit, how can I click on that? I can't actually click on it. There we go. 668. Ah, no, it's this Spiral. Oh, there we go. Spiral. Yeah, here we go. This has got everything. Texture scaling and line drawing. Okay, cool. So yeah, look, shell and spiral mode. I really like these. Put that in. Slope. Ah, here we go. Yeah, slope. Ah, okay, cool. So actually, we can probably use this. These bytes here to do. So at the moment it's line drawing, right? But we can use that line drawing to actually draw textures as well. So yeah, it tells you how to set the screen up. All right. Well, I think this is a task for next time. I'm not gonna. I've got about another 40 minutes left. So what I want to show you in a second, very quickly, is DMA transparency as well, which I think I can just about do. I think, yeah, I should be able to do it with what we've got. Okay, cool. So I'm going to have a read through that before the weekend and get this set up so we can do texture rotating and stuff. Because if we can draw a line from A to B, right, and that those A to B can be anywhere, then we can rotate a quad very easily by basically drawing each line in rows like that. So I think it will be I think it's going to be quite easy to do this. We just treat it as, do we treat it as lines or do we treat it as lookups? I need to have a think about how to do it. I might have a play around with this before the weekend to get some practice in, because this is kind of all new to me in terms of the DMA. I haven't really done a lot of the DMA stuff beyond basic kind of shifting things around and some copying. So I'll show you now is how to do transparency and what that actually means for DMA, and we'll look into this more at the weekend. I think DMA is a big topic, and there's a lot of stuff that we can do with it that are really going to speed things up. It's also used for music as well. So the mod music uses DMA samples, which is basically just DMA's chunks of memory into the sound processor um, very quickly, and allows you to play music very, very quickly as well. So let's change. Oh, raid from Zypho with a raid of 28. Hey, Zypho. Oh, actually, wait, because people might be in the adverts. Oh, no, there we go. Hey, Zypho, thank you very much for the raid. Appreciated. What have you been up to tonight? What have you been playing? Can we get a shout out for Zypho as well, please? It'd be good. We're doing Amiga. Okay, cool. Anything in particular, or just kind of some random stuff? Virtuosity 1200, thank you for the follow. Pat Mick Knowles, thank you for the follow as well. Very much appreciated. Is that Pat Mick or is it Patrick? I can't see. Oh no, it's Pat Mick. Pat Mick Knowles. Okay. He was but lag. Thank you, Andy. More Commodore, yes, indeed. Although we're doing a Mega 65, so it's kind of semi kind of semi Commodore. It is still very, very Commodore at heart, but It's a request night, so mixed bag of games. Okay, cool. Okay, so let's change from doing this line draw DMA, and instead what we'll do. Oh, pardon me. We'll do a copy. We'll copy. We'll just do. Actually, let's keep that on 0. Copy screen scaled, I'll call that. I just want to make sure this is working like it was before. And then I need a simple copy screen. So what we're going to do is we're going to DMA some stuff onto the screen. So the checkerboard pattern again, but this time without scaling. And we're going to use transparency. I'm going to get rid of the line draw because I don't think that's relevant here. Oh. Okay, so we need to run Dma Job. Call it job. Job there. Dma header. And we want a copy job, and we're just going to copy the entire screen this time. So we're going to copy from screen data to 0800, 1000 bytes, not chained, not backwards. Okay, so this should give us our checkerboard pattern back again. Run DMA. Oh, I was thinking. Oh yeah, thank you. I was thinking run DMC. SP. I'm going to give points to SP for that because he said it before I noticed it. When you typed run DMA, I thought you was making a joke about the oh, why is it doing that? Why does it keep bringing up there? There we go. Run DMC. They should have been called the DMC, and then I could type run DMC everywhere, which should be much more fun. But that's why I didn't build. So thank you for that. Where's our checker pattern? Oh, because I'm not actually calling it. There we go. This is a hosted assembler cross. This is kick assembler with so I'm running on a dev kit, which is you can see in the bottom left, which is the bigger screen, and the window in the middle is the emulator. We're doing some work on the emulator quite a lot recently, so I'm doing a lot of I'm loading it in both just to do some comparisons. Actually, so far tonight, not a single thing has been different between the two, so that's actually really good going. But yeah, it is a cross assembler. So yeah, as Monster said, it does. It's a PC assembler based in Java, as in it's written in Java. But it has some nice constructs which make assembly kind of nice and easy, like these macros and things that you get in other assemblers as well. But it's a bit more like JavaScript to me than anything else. Allows you to do like for loops and things like that. Have I got a for loop in here? Yeah, so you've got these nice bits of syntax as well, which makes kind of looping kind of nice and simple. Okay, so so that was our checkerboard thing, screen scale DMA. Okay, so we're just going to do this one here. Now what I'm going to do is I'm going to copy copy transparent data. And it's going to be another DMA job. And this time I'm going to create a chunk of data down here. I'm going to call it transparent data. Now, what do I mean by transparent data? Well, what I mean is we're going to copy something that has some bytes that should not be shown. So I'm going to do it just like this for now. I think it's probably enough to show it like this. Oops, I didn't mean to do that. I meant to do this. So what I'm going to do is I'm going to run this as 8 separate rows because I just want to copy 8 bytes to the screen. So we're going to do 8 jobs here. That's the wrong one. This can be backwards. Actually, it really doesn't matter. So we're going to run this job 7 times. The job is going to be quite simple. It's going to be a copy job. Actually, we could probably just do this by chaining a load of jobs on here. No. Actually, I'm gonna do it like this so we can change these. So we're going to copy 8 bytes at a time. We're not going to chain. We will copy directly to the screen for now, but we will set some these things up. It's the easiest way of doing it. So we've got our source and we've got our destination. So our source is going to be here, and that's going to be our transparent data. So we're going to copy 8 bytes from transparent data to here, and then we're going to repeat 8 times. And I've done it in the wrong place again, damn it. So copy that. There we go. Push that down so I don't keep writing over that. There we go. Okay. So I need to start by resetting transparent data in this. If you copy it, well, yes, you would be, yeah. But what I'm trying to show you is how you would do transparency. The number of bytes that we're doing is kind of irrelevant, but couldn't the macro create those there? That's a good point. I don't know if it can. That's a good point. I don't know. I do not know. That would be nice if it did, though, wouldn't it? Not if you did duplicates. Yeah, that's a very good point. No problem, Zyphos. Thanks for the raid. Very much appreciate it. Have a good night's sleep. Yeah, I've got work in the morning for the first time in a week or so, so I need to be going to bed on time tonight. So sorry, but no Resident Evil tonight. I might play a little bit on Thursday because it's towards the end of the week, but I'm not going to play it tonight. We will finish Resident Evil 1 soon, I think. Can't be that much bigger. Although I'm terrible at games, it might just take me forever, so we shall see. Okay, so we need to set up the transparent data, so we're going to load accumulator with the lowest byte of that and store that at source low. Yeah, so the reason I'm doing it like this is just to show how this works. Obviously, if you were doing 8 bytes, you wouldn't do this. You would do this in a very different way. But if you want to merge kind of large sets of data, then this will help you to do that. This is just to demonstrate how you would go about doing these things. So I don't expect you to. I don't expect you to copy small amounts of data like this. Okay, and then after each one of these, what we're going to do is we're going to take. Oops. advance a row. So, and we're going to do the same with the source, but the source is just advanced by 8. So I'm just going to copy that, add 0.8, source low. Okay, so if I run this, what we're going to see is we're going to see this shape being drawn into that top corner. Well, we will if I actually run that job as well, which I'm not doing. Oh, wait, what? Why has it done that? Hang on. Oh, I know why. Helps if you don't try and draw 1,000 bytes, and instead you just draw 8 bytes at a time. See, there you go. But one problem with that, in fact, let me make it a little bit smaller so it's obvious. So let's just go and change this data a second. So I'm going to make that the middle. So 2, 3, 4. So 1, 2. Used by 0.7 on this. Well, I forgot what that is now. I need to go and have a look at that. 0.7. Yeah. 8 and 9 are the most important things there. Actually, I need to update those because it's less about making a game now. So there you go. So that's the shape that we're copying, but you can see the problem is it takes a chunk out, right? So if you were, for instance, and I use this in Turrican, if you, for instance, so in Turrican it's a waterfall. So let me quickly show you the waterfall I mean, and I'll explain how I'm using it. And I'll show you how it works. So again, this is going to look weird on the main machine because I haven't got the disk set up for it, but it should work in the emulator fine. So ignore what you see on the main screen down there. In fact, let's just turn that off for a second. Okay, and let's go and run ahead to the waterfall over here. So you can probably see that the waterfall is animating downwards, and that's done with the DMA. So that's essentially what's happening there. Is I'm just using that DMA shift, like we're doing the screen shift. I'm just shifting the data through the characters to create that waterfall. But you'll notice there's this wash effect at the bottom, like an animated splash. And what's happening there is a character that's still moving in the top half. This is halfway through a character, right? So you've got this wash and then the animation happening on top of it. So what I'm doing is I move the character down like that, animate it down, and then I copy the waterfall character into another character, and then I copy the wash character on top of it. But obviously, if I do that, I need to maintain the transparency because otherwise, what we would get is we would get a little transparent gap just above the wash, where the wash is overwriting. The transparency of the wash is overwriting the waterfall. And so to do that, we use DMA transparency. Without that DMA transparency, it looks very different. So if I go into DMA animations, if I go in here, water wash chain, DMA copy job. Oh, this is a very different setup in here by the looks of things. Okay, I'm not going to mess with it, but I've obviously changed this since then, I think, because there doesn't seem to be transparency in here at all. Oh, there it is. Yeah, so there we go. If I turn that off. Wait, how is that even working with that? Okay, let me just turn that off and try it, see what happens. Oh yeah, that is right. 0 is the byte. Oh, yeah, that's fine. All right. So if I close this down, we'll go and have it. So remember what that waterfall looked like, and we'll go and have a look at the waterfall with the transparency turned off. And then I'll show you how to do the transparency and what it actually does. So there you can see there's a brown, not brown, grey strip just above the wash. So you can really see the wash animation now quite clearly. Let me just make that a bit bigger. You can see the wash animation here, and you can see how it's a wash animation on a blue on a grey background with a bit of blue underneath it. This grey here is byte 0. This is color 0. The entire background is grey color. You can see it here on the left hand side, um, and actually this blue is actually a character color somewhere in there. I don't know what color number it is, but it is indeed not the background color. So the background color is grey. So if we just copy the wash on top of the waterfall, what we get is we just get all the waterfall bytes are overwritten by the wash bytes, and we end up with this character. So by turning the transparency on, what we do is we say anytime we see a byte that's of a particular type, in this case byte 0, don't write it, ignore it. And then this time when we do it, it ignores those transparent bytes, that byte 0. Why is that not loading? It's really distracting because it's kind of the bugged version is running at the back in the background at the side of me. So let's just make that big. There we go. So you can see now it's those transparent bits are ignored when you copy, and so it looks like that. And it's really easy to do with the macros. It's all set up for you. In fact, I think I saw it. It was correct in that game. So enable transparency is what you need. And all we do is we in our Dma job, which one is it now? This one here. So in this Dma job, just after the header, we say enable transparency, and we tell it which byte is transparent. Well, in our case, the transparent byte is 20 because that's the space. So anytime it sees a space, it will ignore it. And what we should get on the real hardware and on the emulator is it properly overlaying and ignoring any of the space characters. So that's how transparency works. Looks like it's about to bite Shallan. Oh shit! I hope it doesn't. These are the deadly snakes, aren't they? I'm amazed you've remembered these ones, to be honest. Okay, I think that's probably about it that I'm going to do tonight for DMA stuff. We will go through this in a little bit more detail on Saturday. What I will try and do is I will try and get some images put together, so that we can do this with, instead of using characters on the screen, we can actually do this with actually full color images, so we can do something kind of a bit more exciting. We'll use the same code. We'll just use the same code, but I will kind of update it to work with bigger kind of screen areas. At the moment, we're doing 1000 bytes. And so just to go back to what we were doing before, let me just comment this out here. Let's just put Dma transparency so we know what it is when you go back to it. I'll say, can't I? There we go. We're just going to turn this one on again. and we've got these raster kind of checks here. We have an adder. It's yeah, it's not very venomous though, is it? A gambling bot is like Russian roulette at the moment. Oh my god, you got a lot. Steps, you've got a lot of shillings. That's crazy. So yeah, this is on a character level basis, right? So this is scrolling. Well, this is only ever displaying things in multiples of 8 pixels because the character is 8 by 8. We're going to do it at a pixel level. Now the difference is between those two is this is running in round about 2 or 3 raster lines to do this, and this is working on 1,000 um, 1,000 bytes to do this, right? We're going to do the same thing on Saturday, but we're going to do it with a full screen, full color mode image, which means we're going to be working on 64,000 bytes, 64 bytes for every character on the screen. So we can expect this to take roughly 128 or more, 128 to between 100 and 200 cycles, raster lines, sorry, to do this. I wish it was cycles, so it'd be incredible. So it is going to be very expensive, but we are going to be scaling the entire screen. So we're going to be zooming into an image, so it's going to be pretty decent. Um, it's funny how often Maria Whittaker shows up. It's hilarious. Okay, so I don't know if that's been much use to you guys tonight. It's been a learning process for me as well, so I apologize if some of it seems a little bit wishy-washy at first, but hopefully you've got something out of that, and you can see Xemu is or I need to look at actually Prince Faye sent me a thing on how to pronounce it, so I think he said like Xenon, so Zemu. So Zemu, let's call it Zemu from now on. So Zemu will run this, or Zemu, Zemu or Zemu, Zemu. Let's call it Zemu. Okay, Zemu will work with this. It just sounds weird. Or Zemu. Yeah. Oh god, I don't know. Whatever. Anyway, you can see Xemu. That's what I keep calling it. Yeah. You can see how it works well in the emulator, and DMA stuff is working absolutely fine. So feel free to use these in your code. I'm not sure if Monsters has done things like clear screen in Milfork. I honestly haven't looked at much in Milfork. I should probably have a look. But you can probably implement things like that with DMAs. I don't know if there's a DMA system in it or not either. So it's one to take a look. Unfortunately, I've just not had time to look at anything else. Unfortunately, so hey Anton, you're lurking there. I hadn't seen you. How are you doing? Uh, Clear screen DMA is one of the examples. Okay, cool. Yeah, I know there's DMA examples. I haven't actually like looked at the source for them exactly, so I don't know exactly how they work. I probably should look. I mean, the whole point of me doing the Milford thing is to get people interested in other languages as well. So just to kind of reiterate about the competition and why we're doing the competitions the way we are. Let me just turn that off so it's not distracting. So you may be asking kind of why we're doing something in Milfork when this channel is mostly about assembly. The thing is the Mega65 is a powerful machine, right? So I didn't want to just limit the competition entries to assembly. I mean, we've had a basic competition, and that showed that you can write stuff in like the highest of high level languages and still write something that's quite performant. Milfork is a kind of in between. It's not quite a low level language, but it is kind of a little bit. It's a mid level language. It's I mean that's the correct term for it. It's a mid level language. It's lower level than C, which is a high level language, because it doesn't abstract the platform completely away. You still need to know about the platform and the CPU in order to write at Milthorpe. But what it does do is give people who aren't necessarily deeply interested in doing assembly, but are interested in coding, a way of creating stuff for the platform that's very efficient and fast. Thank you very much, Anton, for the bits. Very much appreciated. You're too generous. I owe you 1,000,000 beers at some point, and we will do that. We will do that. Beers or ciders, probably ciders or wine. And yes, likewise, this is why we're going to do the TRSE stuff as well in August as well, to just give everybody a chance to see what options there are out there. We with all of it, yes, indeed, Deft, yes, all of it at once, yeah. Um, we will drink a beer live together, yes, that's for true, that's for sure. Yeah, so I want people to realize that you don't have to write for the Mega65 just in assembly language. It's an exciting machine with a lot of power, a lot of exciting things that you can do on it. So assembly is one option, basic is another option. We've now got Milfork as well, which is another option. C is an option as well. I mean, we could do a C challenge at some point. I'll have to ever think about that one, but we could potentially do a C challenge. I don't actually think we've got much space left in the schedule actually. But yeah, C is an option as well. TRSE is an option. There's a basic intermediary language called 11, which I think Ubic has been doing. I think it's Ubic. Yeah, I think it's Ubic. I can't remember, but 11 is a kind of in between. So I think it's kind of like a very uh, well, I don't know how to describe it. It's kind of, I think it creates basic programs, but it does it using a language that's much easier to work with. Um, so yeah, you've got plenty of options for all sorts of kind of styles of code. Um, and 11 as well has a native IDE for the Mega 65 as well, which is nice. So the 11 is potentially another one as well. Yeah, there we go. That's a better explanation of it. Combined editor and preprocessor package, which enhances basic 10. Yeah, hence the name. I didn't get why it was. I get it now. But yeah, it has a lot of nice features in it. I was listening to the last update and had some pretty decent stuff in it. 2 more weeks until Windows 11. What are you on about? I copied the info from here. There you go. Yeah, so there are plenty of options available. You don't have to write in assembly. This will always be primarily an assembly channel, and we'll keep trying to do more and more assembly. I'm trying to focus more on introducing the features of the Mega 65 to you guys than I think you were like 30 seconds too slow there, Anton. I think seriously beat you to it. Uh, Windows 11 is announced. I thought they said Windows 10 was the last one. Oh god, I'm gonna have to go and have a look up that. Yeah, it has to be a joke because from what I remember, they said Windows 10 was the last Windows, right? And they were just gonna keep updating it. Yeah, that's what I heard. I'm gonna have to have a look at that after this. All right, well, I think I'm gonna call it a night there, then, guys. It's a little bit early, but I do have work in the morning, so I do need to kind of get my beauty sleep, get this pretty face ready for all the Teams meetings tomorrow. We'll see in June the 24th. Yeah, okay, it's a weird one. I hope they don't, because I don't want to have to. I was under the impression that you pay once and that's it. You would just upgrade forever. So let's find someone to raid. As I say, apologies if tonight has been a little bit wishy-washy. I've been learning as we go, so hopefully it's been useful to someone and not just to me. I've definitely learned a little bit from it, so I hope you guys have too. And as I say, this code, I will just dump this code exactly as it is into the repo. And what I will do on Saturday is I will create another folder. Well, I'll copy this code. It will be a copy of it, but I will leave this code as it is so you can play around with it. And let's go and raid Esden, because Esden's a really cool guy. He does a lot of microelectronics design. Last time he was working on his keyboard, and I think he was also working on his Glasgow interface. So let's go and see what he's up to now. Say hello from to him from everybody, and I shall see you all on Thursday, where we're actually going to go back to some C64 and do some Checkanoid. So, okay. Good. Oh, before we go, thank you. Oh, let me start the raid as well. There we go. Thank you, Anton, for the bits again. You're far. I owe you. I owe you a million beers. I really do. Cheers, my man. Okay, I'll see you all on Thursday. Take care, guys. Say hi to Esden, and let's go there now. Bye.
The Gamma version. I'm sure I have the same issue here. Shaolin with 41 people. Shaolin.